Let's discuss about polarity of molecules. First, let's discuss electronegativity. Electronegativity is the power of an atom to attract electrons to itself. These electronegativity values can be found in your table of elements. Now let's discuss electronegativity in terms of the following compounds. So here we have HF, that's hydrogen and fluorine. Now let's draw the electron dot structure of the molecule to show how these atoms are bonded to each other. So here it's bonded by the valence electrons, of course. Hydrogen, 1 valence electron. Fluorine, that's 7 valence electrons. So both of these atoms need one more valence electrons to be stable, and they get that one by sharing this one. It's composed of two atoms, so the obvious shape for HF is linear. Now let's consider their electronegativity. The electronegativity for hydrogen is 2.1. The electronegativity for F is 4.0. So here they have different electronegativity. Again, electronegativity is the power or the strength. The strength of an atom to attract electrons to itself. Again, here they are sharing these electrons here, but they have different, and they are trying to pull this electrons towards themselves. And again, here F is much stronger in pulling this one. So they are sharing this one, but they are sharing this unequally. So we have here unequal sharing of electrons. And here these two electrons will move closer towards F, towards the much more electronegative atom. This will give F a partial negative charge. Again, it's negative because it's the electrons that is coming closer to this F, and then this side becomes partially positive. So here we have a separation of charge. This one is a polar molecule. This one is a polar bond. Then overall, the molecule is a polar molecule. From the word polar, poles, North Pole, South Pole, we have two opposite sides here. The opposite sides is this partially negative side, and the other side is partially positive. So again, HF is a polar molecule. It's composed of a polar bond. Let's have H2. H2, that's dalawang H bonded together, and each of them has one valence electron. And so they need one more valence electron, and they share this one over here. The electronegativity of hydrogen is 2.1, the same thing for this one. So here they have the same strength, the same electronegativity. So they are equally sharing these electrons over here. This is the opposite of polar. So this one is a non-polar molecule. This one is a non-polar bond. This bond over here, and overall, this one is a non-polar molecule. So here, there's no partial charges because again, there's no separation of charge because they have the same strength or the same electronegativity. Let's consider NaCl. So for NaCl, we have this one Na, then the other one is Cl. One valence electron for Na, then for Cl, we have 1, 2, 3, 4, 5, 6, 7. Let's consider their electronegativity first. Na, that is 0.9, then for Cl, that is 3.0. If we compare their electronegativity, Cl is much more electronegative compared to Na. So actually here, instead of just sharing this electron from Na, because Cl is very strong or it's very much electronegative compared to Na, this electron will be completely transferred to Cl. So this Cl will completely steal this electron from the Na. So this gives Cl a formal charge of -1, and it gives Na a formal charge of +1. So again here, this one are formal charges, these are full charges, meanwhile these are partial charges. So here there's formal charges when there's a total transfer of the electrons. Here they are still sharing this electrons over here, so it's just partial charges. So this one, by the way, this one is ionic. So again, pag partial charges, these are polar bonds. Then pag there are formal charges, these are ionic bonds. Ionic bond, this one is an ionic compound. Now if you look on to this table, this will guide us on how we determine if it's polar nonpolar, or ionic. This is from the difference in electronegativity. So it's polar pag yung difference is from 0 to 0.4. So here, the difference here is 0, right? Because they have the same electronegativity. From 0 to 0.4, it's still considered as nonpolar. Then from 0.5 to 1.9, that's polar. So here, that's 2.1 and 4.0. The difference here is 1.9. So this one is a polar bond, a polar molecule. Then this one, the difference here is 2.1. That's 3.0 minus 0.9. That's 2.1. Again, that is ionic. Now, this range can differ sometimes. On some case, ang 0.4 can be considered as polar, and again, this range can differ depending on the sources. Pero let's stick for this range for now.